Okay, so this video is going to be a review of trigonometry, and so what trigonometry starts with? Trigonometry starts with the unit circle. So we've got a circle that has a radius of 1, and that's going to really drive trigonometry. Now, the first thing that I want to know is, what is pi? Now, a lot of people say, oh, well, pi is, let's find the button. A lot of people tell you that pi is that. Well, that's pi. That's not pi. That's the value for pi. But what pi really is, think about it for a second. Some of you know. Pi is the circumference of a circle divided by the diameter of a circle. So pi is a found number. We sort of came up with the concept of a circle, and a circle. What is a circle? That's a good question. Can you answer that one? So I take a point here, and then everything that is 1 unit away from that point makes my little sort of lopsided circle that I just sort of free-handed there. So a circle is the set of all points a given distance, in this case 1, away from a fixed point right there. And then sort of my diameter is the longest possible distance across the circle, and if I take the circumference and divide it by the diameter, I get pi. Okay, so then once around the circle is pi diameters, or I can say once around the circle is 2 pi radiuses. Well, what's a radiuses? Or that's not a word. Once around a circle is 2 pi radians. So here's my radian, same as a radius, and I'm going to go once around, twice around, sort of once around, twice around, 3 times around, 3.14 times around, 4 times around, 5 times around, 6 times around, 6.28 times around. So 1 radian. So a radian and a radius are the same thing. And once around the circle is 2 pi radians. So we can use that as an angle, that basically if I take that distance here and go around my lumpy circle to there, if that distance is 1, then my theta equals 1 radian. It's going to be really, really, really critical that we use radians in calculus. Absolutely critical that we use radians in calculus. So radians are natural, degrees are made up. Man-made. Basically, somebody came up, as far as I can tell, the reason why we have 360 degrees in a circle is because it's approximately equal to 365 days in a year, which has to do with going around in a circle, well, an ellipse technically, but more or less a circle. And then also 360 is divisible by 2, 3, 4, 5, 6, not 7, 8, 9, 10, not 11, 12, not 13 or not 14, 15, 16, 360 divided by 16, probably not. Not quite. But you get the point. It's divisible, 360 is approximately equal to 365 days, and it's divisible by a lot of sort of common numbers. Nevertheless, we want to use radians. So once around the circle, so the way we're going to draw the unit circle is we're going to call this 0 radians. We're going to call this pi radians. We're going to call this 2 pi radians. Call this pi over 2. This one is what? And I can just go, I'm just going quickly. So that's pi over 4. 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4. All right. So then we have our basic trig functions. And so our basic trig functions come from a right triangle that's like this. And we're going to call that theta. We're going to call that y, and we're going to call that x. We're going to call that 1. And so the function that we're going to say is we're going to say that sine of theta is equal to y, and cosine of theta is equal to x, and tangent theta is equal to y over x. Finally, the last thing we're going to do is we're going to say x squared plus y squared is equal to 1 squared, which is Pythagorean theorem, and we're going to write that as our really, really critical identity. No, I should write it the way I should write it, be consistent. Cosine squared of an angle plus sine squared of an angle equals 1. Okay. So sine of theta is my y, cosine theta is my x, and so I start off and I know my sine of 0 is 0, My sine of pi over 4 is root 2 over 2. My sine of pi over 2 is 1. My sine of 3 pi over 4 is root 2 over 2. My sine of pi is 0. Sine of 5 pi over 4 is negative root 2 over 2. Sine of 3 pi over 2 is negative 1. Sine of 7 pi over 4 is negative root 2 over 2. And the sine of 2 pi is 0. It's absolutely critical that you know your unit circle. I can't really go into it right now. Okay, so then, but this is really, really critical. These are really critical. And then you have the reciprocal ones of these. So what's the reciprocal ones? So you've got, well, let me write it this way. Sine of theta is equal to opposite over hypotenuse. And then hypotenuse over opposite is equal to what? Cosecant theta. Cosine theta is equal to adjacent over hypotenuse. And then hypotenuse over adjacent is equal to secant theta. And then tan theta is equal to opposite over adjacent. And then adjacent over opposite is equal to cotan theta. Okay. So then we've got a couple of little functions that I want you to see. And the function that I want you to see is do that y theta, and let's plug it in. Let's just throw it out. We've got, you're going to start off as theta equals 0, y is 0, but then y is going to get bigger and bigger and bigger and bigger and bigger, but then it's going to slow down, and in this region y is going to be constant for a while, and then it's going to shrink, go back down to 0, then it's going to go negative, stay constant for a while, and then start going back to 0. So y is going to go up as the theta is going up, but then it's going to go up more slowly. Then it's going to go back to 0, and then it's going to go down like that. And so we're going to have, that's going to be pi, that's going to be 2 pi, that's going to be pi over 2, that's going to be 3 pi over 2, and this value here is going to be 1, and that value there is going to be negative 1. Now, we could also, there's a lot I could go into, and so I'm going through this really, really quickly because you really should know this from pre-calculus, and you should be able to find resources to go look this up. So going through it really quickly. In another one of my videos earlier on, suppose we did f of theta is equal to a sine b times theta minus c plus d. Well, there we've sort of gone over that. A is the vertical stretch, B is the horizontal stretch, C is the horizontal shift, and D is the vertical shift. There's a lot of implications to that. Okay, so there's y equals sine theta. Very important graph, y equals sine theta. Now, let's do x equals cosine theta. So now, this is my x-axis, this is my theta axis. Now, here, when I start at 0, how far am I in the x direction? I'm 1 in the x direction. So cosine theta is going to start at 1. And then it's going to slowly start off, but then it's going to speed up and go towards 0. Then it's going to shoot through 0, but then slowly go to -1. Then it's going to slowly come up and then rapidly come up to 1. And then it's going to come up and then roll back over until it is back to 1. So it starts off at 1. So the x value, as I walk around the circle, the x value starts at 1, stays pretty close to 1, then starts going more rapidly to 0, and then it goes pretty rapidly through here, but then it slows down as it gets to -1, turns around, goes back up to 0, and then it goes back up to 1. And again, so this is pi over 2. This is pi. This is 3 pi over 2. And this is 2 pi. And that's -1. 1, 0, -1, 0, +1. That's y equals cosine theta. All right. So then tangent has a lot of different things. So tangent theta is opposite over adjacent, or you could think of it as y over x, or you could think of it as sine theta over cosine theta, or you can think of it as the slope of the hypotenuse. So that's something to think about, is that here at a 45-degree angle, if my x and my y are equal to each other, the slope of a 45-degree angle is 1. The slope of a 0-degree angle is 0. The slope of a vertical line is undefined. So tangent goes 0, 1, undefined, -1, 0, +1, undefined, -1, 0. I'll let you think about that. Okay. So again, another theme that's really important is inverse functions. So inverse functions is a function that undoes another function. So suppose I've got y equals the sine of pi over 6. What is the sine of pi over 6? Well, you guys should know what the sine of pi over 6 is. It's 1/2. Well, so how do I, suppose I've got this function here. So I've got that. Suppose I write this. Sine of theta equals 1/2. Well, how do I solve that on my calculator? Well, by the time you've gotten to calculus, you know how to solve it on your calculator. You just do the second sine button. So I do the second sine of 0.5, and it gives me 0.5235. And if I take 0.5235 and multiply it by 6, I get 3.14. So the sine inverse of 0.5 is pi over 6. So how we rewrite that as an inverse function is we say the sine inverse of 1/2 is equal to pi over 6. So sine inverse or inverse sine is the way that you go from the ratio of a sides to an angle. So this function, sine functions take you from an angle to the ratio of two sides. If you have the ratio of two sides, the inverse sine function gives you back the angle. You guys should all know this, and I just want to make a note on notation. You're going to see lots of different notations in your life. You're going to see theta equals sine inverse of x. You're also going to see theta equals arc sine of x. You're going to see theta equals a sine of x. And you're also, maybe if you really stick with it, you're going to see theta equals inv sine of x. This is going to be the least common one. So this is something that somebody tried to develop because they were unhappy with the other notations. I'm not happy with any of these notations. So you just got to get used to it. This does not mean the same as 1 over sine x. So very important. Get that out of your head. I shouldn't even put it in the video. That doesn't exist. This means so sine inverse of x or inverse sine of x. So that's one that you're going to see in a lot of notations, but because there's confusion there, some people and some textbook authors will go to this, where they'll say arc sine, but then you have to write out arc. So then if you look at a spreadsheet program like Excel, or if you look at Excel or OpenOffice Calc or something like that, the formula that they're going to use is a sine x, which is just a contraction of arc sine x. And then some people who didn't like any of those are going to form their own little splinter group, and they're going to come up with inv sine x. And I'm sure there's probably other smaller cults floating around in the world that use other notations. Okay, so these two are most common. You're going to see this a lot in spreadsheets. Don't really worry so much about this one. They're all saying the same thing. And if you go to your spreadsheet, you'll see that your spreadsheet is going to naturally want to do everything in radians. And you're going to, if you want to do it in degrees, you're going to have to tell it explicitly to do it in degrees. So learn your radians, because in calculus and in spreadsheets and in higher math, we're going to need to use radians. And remember that inverse sine of x is the function that undoes sine of x. And then we also have inverse tangent of function, and we have inverse tangent of theta, or inverse tangent of x, and inverse cosine of x, etc., etc. Okay, that's what I have to say in that video.